Hello everyone, this is Kalpana here. In this video, we are going to see a problem from differential equations. So let's get going. Problem: solve 2x square y minus 3y power 4 into dx plus 3x cube plus 2xy cube into dy equal to 0. So here we are given a differential equation of the form some m dx plus m dy equal to 0, right? Given equation which is of the form m dx plus m dy equal to 0, right? For m equal to 2x square y minus 3y power 4 and n equal to 3x cube plus 2xy cube. So here we need to find whether it's exact or not. For that, we'll find partial derivative of m with respect to x and partial derivative of n with respect to partial derivative of m with respect to y and partial derivative of n with respect to x. If the two partial derivatives are equal, then we can say that the given differential equation is an exact equation. If it is not, then we call it as a non-exact equation. Okay, so let's find partial derivatives of m and n. I'll begin with partial derivative of m with respect to y. For m equal to 2x square y minus 3y power 4. Here we are partially differentiating the terms with respect to y, so x will be treated as constant. In the first term 2x square is constant and in the second term 3 is constant. So we can write it as 2x square into partial derivative of y with respect to y minus constant into partial derivative of y power 4 with respect to y, right? Partial derivative of y with respect to y is 1 minus 3 into partial derivative of y power 4 with respect to y is 4y cube, which gives us 2x square minus 3 4s are 12 y cube. Fine. Now we'll find partial derivative of n with respect to x. For n equal to 3x cube plus 2xy cube, right? Here we are finding partial derivatives with respect to x, so we'll treat y as constant. In the first term 3 is constant and the second term 2y cube is constant, right? So we'll write it as 3 into partial derivative of x cube with respect to x plus constant 2y cube into partial derivative of x with respect to x, which gives us 3 into partial derivative of x cube with respect to x is 3x square plus 2y cube into partial derivative of x with respect to x is 1, which gives us 3 3s are 9x square plus 2y cube, right? Now compare this to which shows that the partial derivative of m with respect to y is not equal to partial derivative of n with respect to x, right? So therefore partial derivative of m with respect to y is not equal to partial derivative of n with respect to x. This shows that the given differential equation, considered as 1 is not exact, right? Now in order to solve this problem, we have to reduce this non-exact equation to an exact equation, okay? And later we'll see. Now we can write the given equation as 2x square y dx minus 3y power 4 dx plus 3x cube dy plus 2xy cube dy equal to 0, right? And you can take x square common from the first term and the third term and y cube common from the second term and the last term, right? So I'll write the first term and third term firstly. Now I'll write the remaining terms. Okay, let's now take x square common from the first two terms. We'll get x square into 2y dx plus 3x dy plus, take y cube common here, or minus y cube. Okay, I'll take plus y cube common, so I'll get y cube times minus 3y dx plus 2x dy equal to 0. Right, here we are having x square, and this x square can be written of x power something into y power some power, y power something form, right? You can write this x square as some x square into 1, right? And here we need to get a term of y. Since we know that y power 0 equal to 1, right? Let's replace this 1 by y power 0, then you'll get x square y power 0. Likewise, here you're having y cube. You can write this y cube as 1 into y cube, so that you'll get some x term. You can write a term which is an x in LHS, not LHS, left side or beside y cube. Since we know that x cube is 1, right? Just replace this 1 by x cube. Sorry, it's x power 0. Then you'll get x power 0 into 3. Now you can replace x square by x square y power 0, and replace this y cube by x power 0 into y cube, which is an x power something into y power something form, right? Then this becomes x square y power 0 into 2y dx plus 3x dy plus, we can write y cube as x power 0 into y cube into minus 3y dx plus 2x dy equal to 0, right? Consider it as some equation 2, which is of the form, right? We got equation 2, which is of the form x power alpha, not alpha, let's take AB, x power a y power b into my dx plus nx dy plus x power c y power d into py dx plus qx dy equal to 0. Now by comparing these two, we'll get the values of unknowns, where a equal to 2, b equal to 0, c equal to 0, d equal to 3, and m equal to 2, n equal to 3, it's n, okay, p equal to minus 3, q equal to 2, right? Since the given equation is written of this form, so here x power alpha y power beta will be the integrating factor. Okay, now using some methods we'll find alpha and beta. Let x power alpha y power beta be the integrating factor. Here we need to find alpha and beta. We have a equal to 2, b equal to 0, c equal to 0, d equal to 3, m equal to 2, n equal to 3, p equal to minus 3, and q equal to 2. Use a formula to find two equations. A plus alpha plus 1 by m equal to b plus beta plus 1 by n, and the other one c plus alpha plus 1 by p equal to d plus beta plus 1 by q. Okay, now substitute the values. We'll have 2 plus alpha plus 1 by m, 2 equal to b, 0 plus beta plus 1 by n, 3, which gives us alpha plus 3 by 2 equal to beta plus 1 by 3. right? From this just make a cross multiplication. We'll get 3 times alpha plus 3 equal to 2 times beta plus 1, which gives us 3 alpha plus 9 equal to 2 beta plus 2. Now bring this 2 beta to LHS, take this 9 to RHS, you will get 3 alpha minus 2 beta equal to 2 minus 9, which gives alpha 3 alpha minus 2 beta equal to minus 7, and consider it as equation A. Now substitute the values of C, D, P, Q in this formula. We'll get
Here substitute the values of C, D, P and Q. You'll get 0 plus alpha plus 1 by P, which is minus 3, equal to 3. D is 3. So you'll get 3 plus beta plus 1 by Q, which is 2. Which gives us alpha plus 1 by minus 3 equal to beta plus 4 by 2. Now make the cross multiplication. You'll get 2 times alpha plus 1 equal to minus 3 times beta plus 4, which gives us 2 alpha plus 2 equal to minus 3 beta minus 3 4s are 12. Now bring this term to LHS and take this 2 to RHS. You'll get 2 alpha plus 3 beta equal to minus 12 minus 2, which gives us 2 alpha plus 3 beta equal to minus 14. Consider as equation B.
observe A and B. So here we are having minus 2 beta, here in second equation we are having 3 beta, right? In order to cancel the terms involving beta, we need a 3 here and we need a 2 here, right? So we'll just multiply equation A by 3 and equation B by 2. Three threes are 9 alpha minus 3 twos are 6 beta minus 3 sevens are 21. 2 twos are 4 alpha plus 3 twos are 6 beta equal to 14 twos are 28. Which where minus 6 beta plus 6 beta gets cancelled. 9 alpha plus 4 alpha gives 13 alpha equal to minus 21 minus 28 gives minus 49. From this we'll get alpha equal to minus 49 by 13, right? Therefore alpha equal to minus 49 by 13. Now put this alpha value in any of these two equations. So let's begin with the first one. I'll show you for the two equations. Okay, so we are having the value of alpha, right? Let's take this 2 beta to RHS and bring this minus 7 to LHS. Then you'll get 3 alpha plus 7 equal to 2 beta. Now substitute the value of alpha. Since alpha equal to minus 49 by 13, okay, equal to 2 beta. This gives us 49 into 3. So minus 147 plus 13 sevens are 91 by 13 equal to 2 beta. Minus 147 plus 91 gives minus 56 by 13. Okay, now we can write this as some 2 beta equal to minus 56 by 13 or beta equal to minus 56 by 13 into 2. 2 ones are 2 twos are 4, 2 eights are 16, which gives us minus 28 by 13. Beta equal to minus 28 by 13. Now coming to the second equation, let's try this also. Now bring this minus 14 to LHS, take this 3 beta to RHS, you'll get 2 alpha plus 14 equal to 3 beta. Now substitute the value of alpha, you'll get 2 times minus 49 by 13 plus 14 equal to 3 beta, which gives us minus 98 plus 13 into 14 by 13 equal to 3 beta, right? So minus 98 plus 182 by 13 equal to 3 beta. 182 minus 98 gives 17 minus 9, 8. So I'll get 84 by 13. Equal to 3 beta, or we can write this as beta equal to 84 by 3 into 13. 3 2s are 6, 3 8s are 24, which gives us 28 by 13. Okay. Well, we need to get minus here, right? Something went wrong. Here it's not 3 beta, it's minus 3 beta. Fine. Okay. So you got the same answer, right? Therefore, alpha equal to minus 49 by 13 and beta equal to minus 28 by 13. So we got the values of alpha and beta. Now we'll get the we'll find the integrating factor using x power alpha, y power beta. Just substitute the values of alpha and beta in this. Since alpha equal to minus 49 by 13 and beta equal to minus 28 by 13. So integrating factor becomes x power minus 49 by 13 into y power minus 28 by 13. By multiplying this integrating factor to the given equation, the given equation can be reduced to an exact equation. So let's see that. Multiplying integrating factor x power minus 49 by 13, y power minus 28 by 13 to 1. Okay. I'm just writing the given equation here. This gives us, we can write this as into the first term or quotient of dx plus x power minus 49 by 13 into y power minus 28 by 13 into the second term. Now we'll write this as 2x power minus 49 by 13 into x square, y power minus 28 by 13 into y minus 3x power minus 49 by 13 into y power minus 28 by 13 into y power 4 into dx plus 3 x power minus 49 by 13 into x cube y power minus 28 by 13 plus 2 x power minus 49 by 13 into y power, okay, you have one x term here, right? So into x, y power minus 28 into 13, it's 28 by 13 into y cube into dy equal to 0. Okay, if the bases are equal, just add the powers. This gives us 2x power minus 49 by 13 plus 2 y power minus 28 by 13 plus 1 minus 3x power minus 49 by 13 into y power minus 28 by 13 plus 4 into dx plus 3x power minus 49 by 13 plus 3 into y power minus 28 by 13 plus 2x power minus 49 by 13 plus 1 into y power minus 28 by 13 plus 3 into dy equal to 0. Right? Now let's simplify all the powers which are necessary. Right? Fine. I'll begin. Okay. Minus 49 by 13 plus 2 gives minus 49 plus 13 2s are 26 by 13. So you'll get 6 minus 3, 49 minus 26 is 23 minus 23 by 13. Minus 28 by 13 plus 1 gives minus 28 plus 13 by 13, which gives minus 15 by 13. Minus 28 by 13 plus 4 gives minus 28 plus 13 4 is 52 by 13. 52 minus 28 gives 24 by 13. Minus 49 by 13 plus 3. Minus 49 plus 13, 3s are 39 by 13 gives minus 10 by 13. And minus 49 by 13 plus 1 gives minus 49 plus 13 by 13, which gives minus 36 by 13. And last one, minus 28 by 13 plus 3 gives minus 28 plus 13, 3s are 39 by 13, which gives 11 minus, no, just 11 by 13. Okay, this gives us 2x power minus 49 by 13 plus 2 minus 23 by 13 into y power minus 28 by 13 plus 1 minus 15 by 13 minus 3x power minus 49 by 13 into y power minus 28 by 13 plus 4, 24 by 13 into dx plus 3 x power minus 49 by 13 plus 3 is minus 10 by 13 into y power minus 28 by 13 plus 2 x power minus 49 by 13 plus 1 gives minus 36 by 13 into y power minus 29 by 13 plus 3 minus, sorry, it's 11 by 13 into dy equal to 0. Now consider as equation 3. The reduced equation is considered as equation 3, which is of m dx plus n dy equal to 0 form. Or you can write it as m2 dx plus n2 dy equal to 0 for m2 equal to the quotient of dx and for n2 equal to the quotient of dy, which is of the form m2 dx, sorry, I'll write m and n, okay, m dy equal to 0 for m equal to 2x power minus 23 by 13, y power minus 15 by 13, minus 3x power minus 49 by 13, y power 24 by 13, and for n equal to 3x power minus 10 by 13, y power minus 28 by 13, plus 2x power minus 36 by 13, y power 11 by 13. Okay. So here, if the partial derivative of m with respect to y equal to partial derivative of n with respect to x, then we can say that the reduced equation is an exact equation. Okay. If it is not equal, then it will be a non-exact equation. So let's find partial derivatives of m and n for m equal to this one and for n equal to. Okay. So here we are going to find partial derivative of m with respect to y and partial derivative of n with respect to x. For m equal to 2x power minus 23 by 13, y power minus 15 by 13, minus 3x power minus 49 by 13, y power 24 by 13. Right? Since we are finding partial derivative of terms with respect to y, so we will treat x as constant. Here in the first term 2x power minus 23 by 13 is constant. In the second term 3x power minus 49 by 13 is constant. So we can write this as 2x power minus 23 by 13 into partial derivative of y power minus 15 by 13 with respect to y, minus 3x power minus 49 by 13 into partial derivative of y power 24 by 13, which gives us 2x power minus 23 by 13 into partial derivative of y power minus 15 by 13 with respect to y is minus 15 by 13 into y power minus 15 by 13 minus 1, minus 3x power minus 49 by 13 into partial derivative of y power 24 by 13 with respect to y is 24 by 13 into y power 24 by 13 minus 1. So let's simplify minus 15 by 13 minus 1 and 24 by 13 minus 1. Okay. Then this becomes 2 into minus 15 by 13, or just write one more time, one more step. Y power minus 15 by 13 minus 1 is minus 28 by 13, minus 3 into x power minus 49 by 13 into 24 by 13 into y power 24 by 13 minus 1, 11 by 13. This becomes 2 into minus 15 by 13 into x power minus 23 by 13, y power minus 28 by 13 minus 3 into 24 by 13 into x power minus 49 by 13 into y power 11 by 13, right? This gives us minus 2 15s 30 by 13 into x power minus 23 by 13, y power minus 28 by 13, minus 3 into 28, 72 by 13, x power minus 49 by 13 into y power 11 by 13. So this is the partial derivative with respect to y, result obtained from dou m by dou y. Let's now find the partial derivative of n with respect to x. For n equal to quotient of dy, that is 3x power minus 10 by 13, y power minus 28 by 13 plus 2x power minus 36 by 13, y power 11 by 13. Here we are finding partial derivatives of terms with respect to x. So we'll treat y as constant. In the first term 3, y power minus 28 by 13 is constant, and in the second term 2, y power 11 by 13 is constant, right? So we'll write it as constant into partial derivative of x power minus 10 by 13 plus 2 y power 11 by 13 into partial derivative of x power minus 36 by 13. This gives us 3y power minus 28 by 13 into partial derivative of x power minus 10 by 13 with respect to x is minus 10 by 13 into x power minus 10 by 13 minus 1 plus 2 into y power 11 by 13 into partial derivative of x power minus 36 by 13 with respect to x is minus 36 by 13 into x power minus 36 by 13 minus 1, which gives us, now we need to simplify minus 10 by 3 minus 1 and minus 36 by 13 minus 1. It's 13, okay, not 3, sorry. Right. You can write this as 3 into minus 10 by 13 gives minus 30 by 13 into x power minus 10 by 13 minus 1 is minus 23 by 13. It's x power, okay, into y power minus 10 by 13, sorry, y power minus 28 by 13, okay, plus 2 into minus 36 by 13 gives minus 72 by 13 into x power minus 36 by 13 minus 1 is minus 49 by 13 into y power 11 by 13. Okay, by observing these two, we can say that the partial derivative of n with respect to, partial derivative of m with respect to y equal to partial derivative of n with respect to x. See, you have the same terms here. Okay, therefore partial derivative of m with respect to y equal to partial derivative of n with respect to x. This shows that the reduced equation, that is equation 3, is exact. So from this we can say that we have reduced the given non-exact equation to an exact equation by multiplying it with an integrating factor x power alpha y power beta, right? For alpha equal to minus 49 by 13 and beta equal to minus 28 by 13, right? Now we came to know that the reduced equation is an exact equation. Now we need to find the general solution to the problem, to the given equation, which is given by the general solution of the exact equation, equation 3. Okay. We know that the general solution to an exact equation is given by integral m dx treating y as constant plus integral terms of n free from x into dy equal to c, right? So here let's now use each integral. We'll find each integral separately for our convenience, and finally we'll find the general solution to our problem. Integral m dx treating y as constant equal to integral for m equal to 2x power minus 23 by 13 y power minus 15 by 13 minus 3x power minus 49 by 13 y power 24 by 13 into dx. Here we should treat y as constant. In the first term 2 y power minus 15 by 3 is constant. In the second term 3 y power 24 by 13 is constant. So we'll write it as 2 y power minus 15 by 13 into integral x power minus 23 by 13 into dx minus 3 y power 24 by 13 into integral x power minus 49 by 13 into dx, which gives us 2 y power minus 15 by 13 into x power minus 23 by 13 plus 1 by minus 23 by 13 plus 1. We need to simplify minus 23 by 13 plus 1 here. Okay, minus 3y into 3y power 24 by 13 into integral x power minus 49 by 13 is x power minus 49 by 13 plus 1 by minus 49 by 13 plus 1. Right? Let's simplify minus 23 by 13 plus 1 and minus 49 by 13 plus 1, which gives us minus 23 plus 13 by 13. 23 minus 23 plus 13 gives 10, minus 10 by 13. Okay, and here we'll get minus 36 by 13. Two y power minus 15 by 13 into x to the power minus 10 by 13 by minus 10 by 13, it's 13. Okay, minus 3 y power 24 by 13 into y to the power minus 36 by 13 by minus 36 by 13. Now we can write this as 2 into 1 by minus 10 by 13 can be written as minus 13 by 10 into x power minus 10 by 13 into y power minus 15 by 13. Okay, minus 3 into 1 by minus 36 by 13 can be written as minus 13 by 36. Reciprocal of minus 36 by 13 is minus 13 by 36 otherwise. Okay, and it's x not y, sorry. X power into x power minus 36 by 13 y power 24 by 13. Right? See, we can take 13 common from these two terms. We'll get 13 into, or just take minus otherwise. Okay, take just 13 common, you'll get 2 by 10 into x power minus 10 by 13 y power minus 15 by 13 minus into minus plus 3 by 36 into x power minus 36 by 13 y power 24 by 13. This gives us 3 into 1 by 5 into x power minus 10 by 13 y power minus 15 by 13 plus 1 by 12 into x power minus 36 by 13 y power 24 by 13. You can simplify this. Take the LCM of 5 and 12, which is 60. You'll get into, okay, what into? 60 is the LCM, and here in the denominator first term you're having 5, so multiply this term. I mean here you need to multiply with 12. 12 x power minus 10 by 13 y power minus 15 by 13 plus, here you having 12, right? So multiply it with 5, or just make a cross multiplication. See, some terms which are in x and y form, you'll get right 12 into this plus 5 into this, you'll get 5 into x power minus 36 by 13 y power 24 by 13. It's minus, okay, minus. Now we can write this as 3 by 16, it's 13, right? 13 by 60 into 5 x power minus 36 by 13 y power 24 by 13 minus 12 x power minus 10 by 13 y power minus 15 by 13. So this is the result obtained from the first integral. Now coming to the second integral, terms of n free from x into dy. Since you don't have any such term which is free from x in n, right? So the integral terms of n free from x into dy is 0. Now the general solution will be integral terms of integral m dx treating y as constant plus terms of n free from x into dy equal to c. From this we'll get result obtained from the first integral is 13 by 60 into 5 x power minus 36 by 13 y power 24 by 13 minus 12 x power minus 10 by 13 y power minus 15 by 13 plus 0, the result obtained from the second integral is 0 equal to c, or we can write this as 13 by 60 into 5 x power minus 36 by 13 y power 24 by 13 minus 12 x power minus 10 by 13 y power minus 15 by 13 equal to c. Now we can take this constant to RHS, then you'll get 5x power minus 36 by 13 into y power 24 by 13 minus 12x power minus 10 by 13 into y power minus 15 by 13 equal to c into 60 by 13. Let c equal to c into 60 by 13. Then we'll get 5 x power minus 36 by 13 y power 24 by 13 minus 2 12 x power minus 10 by 13 y power minus 15 by 13 equal to c is the required solution. Which completes the problem. Well, we have seen a problem from differential equations in this video using integrating factor x power alpha y power beta. I hope you'll understand. We'll see you in the next video. Until then, bye bye.